We think of today's large language models as these incredible reasoning engines. They can write code, they can analyze super complex documents, solve problems that really seem to require genuine intelligence. But what if I told you that all of this genius has a hidden and frankly pretty surprising vulnerability? That a single, totally random sentence can completely derail its logic, raising some major questions for AI safety and alignment.
So here's how we're going to break it all down. First, we'll look at this hidden flaw up close. Then we'll see how researchers actually engineered a test just to measure it. After that, we'll explore ways to build a more focused AI, understand why this is so critical for the real world, and finally, get into the difference between just being smart and being truly robust.
All right, let's dive right in with the problem itself. It all starts with a super simple puzzle that, believe it or not, exposes this massive weakness in even the smartest AI systems out there. It kind of peels back the curtain on the illusion of their genius.
Okay, check this out. On the left, you've got a standard math problem you'd see in grade school. An advanced AI has no trouble with this. It figures, okay, Claire will be 20 in 2 years, so she's 18 now. Jessica is 6 years older, so Jessica is 24. Easy. But now look at the right. The only thing that's changed is one completely irrelevant sentence about Claire's dad. Logically, that shouldn't matter at all, right? But for the AI, it changes everything. The model gets totally confused, it latches onto the wrong numbers, and it fails. And this brings us to a really critical question. If these models are so smart, so good at complex reasoning, why does one little piece of useless information throw them off so completely? This isn't just some funny little bug. It points to a pretty fundamental gap in how they think, and that's a core challenge for AI alignment.
So how do you even begin to get to the bottom of this? Well, researchers at Google knew that just looking at a few examples wasn't going to cut it. To really understand what was going on, they had to put this whole phenomenon under a microscope and measure it systematically. In other words, they had to actually engineer distraction.
And they gave this specific failure a name, which is super important. It turned it from a weird anecdote into something they could actually measure: distractability. And that's the core idea here. It's how much a model's accuracy can be totally thrown off by context that shouldn't even matter.
So to put distractability to the test, the team built a specialized dataset called GSMIC. What they did was they took thousands of regular math problems and then methodically injected them with these irrelevant sentences, these distractors, that were specifically designed to trip up the AI without actually changing the correct answer.
And the results? They were pretty striking. On the original, clean problems, the model was scoring in 94% accuracy. That's a solid A. But once you add in those distractors, performance just plummeted, dropping by more than 16 percentage points. The AI's A+ grade suddenly dropped to a C, all because of a little bit of noise.
But here's the number that really tells the story. The researchers looked only at problems the AI could solve perfectly to begin with. Of that group, the model could consistently handle them with any kind of distractor less than 18% of the time. Let that sink in. For over 80% of the problems it absolutely knew how to solve, a little bit of distraction was enough to make it fail. Now, finding a flaw is one thing, but fixing it, that's the real challenge. So the next phase of this work was all about forging a defense, trying to build a more focused AI that could actually resist these kinds of distractions. And this is a huge step in alignment research. You move from just diagnosing the problem to trying to fix it. And one of the most effective methods was, well, almost ridiculously simple. They just told the AI what to do. By literally adding this one sentence to the prompt, feel free to ignore irrelevant information. The model's performance shot right back up. It's a great reminder that sometimes the direct approach is the best one.
Okay, now for a more powerful technique. This one's called self-consistency. The idea here is pretty clever. Instead of asking the AI to solve the problem just once, you ask it to solve it multiple times, each time trying a different path of reasoning. Sure, some of those attempts might get tripped up by the distractor, but many of them won't. Then you just take a vote, and the most common answer is almost always the right one.
They also found that showing is way better than telling. So instead of just giving the AI a clean example, they showed it an example that itself had a distractor in it, along with the correct reasoning that just ignored it. This kind of in-context learning made the model way better at spotting and ignoring useless information when it saw it for real.
So we've seen the flaw, and we've seen some pretty cool fixes. But you might be wondering, why does this academic stuff matter so much? Because the real world isn't a clean data set. It is messy. And this research has a huge influence on how we build safeguards for AI deployment.
So it all really boils down to this. If an AI can't reliably tell the difference between signal and noise in a simple math problem, how can we possibly trust it with decisions where the stakes are incredibly high? This is one of the absolute core questions for AI safety. I mean, just think about these fields. A doctor has to filter out tons of irrelevant patient history to make the right diagnosis. A financial planner needs to ignore all the market noise. A self-driving car absolutely has to focus on real hazards, not just visual clutter. In these worlds, being able to ignore irrelevant stuff isn't just a nice feature, it is a critical safety requirement. So, what's the deeper meaning in all of this? This whole investigation, it's not just about getting an AI to be better at math. It's about a fundamental journey from a tool that is brittle to one that is truly robust. And that's really the holy grail of AI safety research. And this gets right to the heart of it. Is the AI actually showing true comprehension, or is it just an expert at cramming for the test? You know what I mean? The student who crams memorizes patterns for specific problems, but they totally fall apart when the format changes. The student who truly understands the material can figure out the core principles of a problem, even when it's surrounded by noise.
And that's really the ultimate takeaway here. This research doesn't just show that AIs can get distracted, it puts a giant spotlight on the critical gap that exists between an AI seeming intelligent on a specific test and possessing the kind of flexible, robust understanding we need for real-world reasoning. In closing that gap, that's one of the biggest challenges in AI today. Which leaves us all with this final, really big question. We have built these incredible tools that can process nearly all of the world's information. But the next great frontier is teaching them the difference between all that information and the wisdom to know what actually matters.
This is for entertainment purposes only.